So in this video we're going to look at an improper integral that has infinite upper and lower limits of integration. So the integral we're interested in evaluating is the integral from negative infinity to infinity of 4 over 16 plus x squared. So I'm going to go ahead and rewrite this, negative infinity to infinity, and we have 4 over 16 plus x squared dx. And then what we're going to do is recognize a couple things here. One, we could use the table, a comprehensive table of integrals that we've been provided to integrate this. That's one thing we could do. Two, we look at this and we see that we have a Pythagorean form in the denominator, so we could use trigonometric substitution to resolve this integral. I'm going to go ahead and use the comprehensive table of integrals, equation number 9. And what I'm going to do is break this into the sum of two integrals. So I'm going to factor the 4 out front, right? The 4 could be factored out front of this integral because it's just a constant. So I really have a 1 over 16 is really like a 4 squared plus x squared form. So I have something where in my comprehensive table of integrals a is equal to 4. What I'm going to do is take and break this interval from negative infinity to infinity into two. I'm going to go from negative infinity up to 0, and then I'm going to go from 0 to infinity. And we'll attack the integral by taking the sum of two integrals using these as the limits of integration. So I'm going to take the limit, and I'm going to let a approach the negative infinity. I'm going to say, hey, take the limit as a approaches negative infinity. And I'm going to take the integral from a to 0 of 1 over the 4 squared plus x squared dx. And then I'm going to go plus, and then I'm going to pick up and I'm going to run from 0. I'm going to pick right up at 0, right? Just pick right up at 0 and run to b. I'm going to pick up at 0 and run to b, but we're going to take the limit on the second integral as b goes to infinity. So we're breaking the negative infinity to infinity up into two chunks that we can attack individually. So we're going to run this from 1 over, this is going to be 4 squared plus x squared. And we'll close off this parentheses. And then if we just use the identity from the comprehensive table of integrals, we can now rewrite this. We can say it's going to be 4 times, and we're going to have the limit as a goes to infinity of, and we're going to get 1 over 4 from the formula here. We're going to get 1, or the identity, we're going to get 1 over 4 times the tangent inverse of x over 4, and we're going to run this from a to 0, taking the limit as a goes to, that should be a negative infinity right there, negative infinity, plus, and then we're going to integrate this. So we're going to take the limit as b goes to infinity, and we're going to get of a fourth times the tangent inverse of x over 4 running from 0 to b. And then I want to recognize that the 1/4 shows up in each of the two terms, so the 1/4 could be factored out. And once we factor it out, we get 4 divided by 4 is 1. So this simplifies to that. Now we put in our limits of integration. So here this is going to equal, we're going to take the limit as a approaches negative infinity of, we have the tangent inverse of, 0 over 4, so we get 0 over 4 minus the tangent inverse of a over 4, plugging the a in, plus, now we're going to have the limit as b goes to infinity, plug the b in, we get the tangent inverse of b over 4 minus the tangent inverse, and we plug in 0 over 4 here. So we just need to evaluate these limits. So remember, on a previous slide we did a limit involving the arctan, a previous video in this sequence of improper integral videos. And what we learned about the arctan function, which is the same as the tangent inverse function, we learned that the domain goes from negative infinity to infinity, and the range is going to go from negative pi over 2 to pi over 2. And the other thing that we learned was that as the inputs approach infinity, the outputs approach pi over 2, and as the inputs approach negative infinity, the outputs approach negative pi over 2. So this was our range. The second set of things is the range, and this was a result from trigonometry class. So when I look at this, I can actually evaluate these limits. The tangent inverse of 0 over 4 is the tangent inverse of 0, and the tangent inverse of 0 is just 0. So I get a 0 there. Minus. So I'm going to take the limit as a goes to negative infinity. So as a goes to negative infinity, a divided by 4 also goes to negative infinity. So as a goes to negative infinity, the inputs to the tangent inverse function approach negative infinity. And as the inputs to the tangent inverse approach negative infinity, the outputs approach negative pi over 2. And like I said, this is from trigonometry class. And then we go plus over here. And then we need to take the limit as b becomes infinitely large. But as b becomes infinitely large, b over 4 becomes infinitely large. And as the inputs to the tangent inverse function become infinitely large, the outputs approach pi over 2. You never get pi over 2, but in the limit it's pi over 2. So we get a pi over 2 here, minus the tangent inverse of 0 is just 0. And then we can simplify. We have a double negation, which makes this a plus. So we have pi over 2 plus pi over 2 is 2 pi's over 2, which is just pi.